All right, so then today we're moving on to 5.2, relations and functions. Oh, see, there was our timer. We did great today going over prayer and questions. All right, so today then, objectives. We're going to identify relations and functions, okay, how they're related to each other. We're going to identify the domain and the range of a relation. And we're going to represent relations and functions using sets of ordered pairs, tables, mapping diagrams, and graphs. So all of the above. Do you need a pencil, bud? You have one? Okay, I was just checking. You need a pencil? Okay. Okay. All right. So first of all, let's get started with the relation here. Okay, so the relation is a connection or association between any two, it could be or more, items. So an example would be the item and its price. Okay, or it could be the number of items that you buy and the price. It could be your age and your IQ. It could be your height and your weight. It's just any two things or more and their relation, like how they're connected or associated. Okay, so any set at all of ordered pairs is a relation. Okay, relations are represented in a variety of ways. Okay, we can have a set of ordered pairs named with a capital letter. So this right here is a relation. So we're saying relation A, and the ordered pairs that are contained in it, we use that set notation. So we have how many ordered pairs are in this set? 4. Okay, so maybe it's a square, maybe it's a rectangle. We know it would be a quadrilateral of some kind, right? It's 4 points, or if we connected them. Or maybe it's just a graph of we have negative, so it's not going to be an item and its price because we can't have that negative, but it's a set or a relation of some type. Okay, so that's one way that we can represent them. Okay, is that set notation. Another way is to use the table. Okay, so if we put, it's the same information, our x is -3 and our y is 5, just like this ordered pair. 2, 2, 2, 4, and 4, -1. So we represented it as a list or a set of ordered pairs, as a table. I'm going to have to move this up. What's number 3? A graph. Okay, so it can also be represented as a graph in this case. That's our third representation. And the fourth one I had to squeeze in because it came later in your notes, I'm sorry, is a mapping diagram. I want to know, what's your connection? What do you know about mapping diagrams? Have you seen these before? No? Okay, so we should have probably seen them in 7th or 8th grade. But these are my x values in the first side. These are my y values. How come there's only 3 x values? One repeats. Yeah. Okay. So then if you remember this now, okay, my mapping diagram is not complete. How do I complete it? We have to draw the lines because -3 goes with 5 and 2 goes with 2 and it goes with 4. So we draw another line. And then 4 goes with -1. That is a mapping diagram. Very nice. Okay. So we do have to complete it. And that's what I, again, wanted to see, like, what do you remember about it? So very good. Typically, like, these can be in different orders. We could have put -1, right, -1, 2, 4, and 5. Those would have been in numerical order. Doesn't matter. It's in the grand scheme of things. Okay, just as long as you have it. So those are the 4 ways we're going to represent relations. So we've got the ordered pairs up here, the table for number 2, the graph for number 3, and the mapping diagram are the 4 ways. Okay, then we break down and we need to look at this vocabulary. Domain is the first element of an ordered pair. That's just your x coordinate. It's another, domain is the same thing as your x. Okay, that's why it says here x coordinate. Your range is the second element of the ordered pair. So that's your y. It's your y coordinate. So if I was looking at this mapping diagram, what would all these numbers be? The domain or the range? These are the domain. So what would all these values over here be? The range. You got it. Okay, so if I was looking at the table, what is this column? Domain. What is this column? Range. Okay, it's a little harder to see in the graph, but it's always the first number. Your domain is that -3, the 2, the 2, and the 4. Okay, it's always the first number. Range is your second. So, but it's really easy to see in the table and the mapping diagram. Perfect. Okay, so let's look at example 1. State the domain D and the range R of relation A, which is this relation, right? Well, we just pointed it out in a lot of different examples. So the domain equals the set of what? The -3, 2, just 2, and then 4. Yeah, you got it. Perfect. Okay, and so what's your range of set A? 5, 2, 4, -1. Excellent. Ta-da! Not really. Again, like if you put them in numerical order, great, but I don't get nitpicky about that. Like if you're listing them out, then it's at this point in the game, I'm okay. Okay. All right, then the last little note down there is a function. What is a function? Okay, so a function is a special relation. Okay, so a function is a what? It's a special relation, but it is a relation. Okay. Okay, but yes, it is special. So it's in which every element in the domain is paired with one and only one element in the range. So each x coordinate is paired with only one y coordinate. So each x is paired with only one y. Okay. So is set A a function? Why not? Okay, because this x, right, this 2 was paired with 2 and it was paired with 4. This makes it not a function. Okay, is it a relation? Yes, but it's not a function. Okay, it's like saying, I'm wearing tennis shoes, but am I wearing Adidas? No, but I'm still wearing tennis shoes. Okay, Bailey is wearing tennis shoes. Is she wearing Adidas? No, but she's still wearing tennis shoes, right? This function is just a smaller subset of the relation. All right, perfect. So let's look at example 2. Okay, it says write a set of ordered pairs and draw a mapping diagram of the relation illustrated by the graph. And then is this relation a function? All right, so let's see, set of ordered pairs. So let's start there. So let's name this set B, because we already had an A. So let's name it set B, because I didn't give you a name. So we're going to say B equals, we're going to use our set notation, and we need to list our ordered pairs. So let's start here. What's this one? -2, 3. Nice job, Connor. Okay, so that's 1. How about this point over here? What's that one, Chase? 1, 1. Awesome. Okay, let's go, Abigail, down here. What's this point? Perfect. 4, -2. And Josie, what's this last point here? Oh, we want to go left and right first. -1, -3. So -1, -3. Perfect. Okay, and I'm going to close my set notation. All right, so that was the set of ordered pairs. Now we need a mapping diagram. Okay, so what numbers am I going to put in my domain over here? Let's see. Bailey, can you tell me what numbers are going to go in the domain side over here? Good. Perfect. And Cheyenne, tell me what numbers are going to go in that range circle. Okay. So again, they look more complicated later if we put them in numerical order, but we don't have to do that. And so I'm going to make this a different color. So what's my -2 go with? 3. What's my 1 go with? 1. What's my 4 go with? Ooh, 4 goes with -2 this time. Right, 4 and -2. We went 4 and -2 to get this point. Okay. And then my -1 goes with -3. Okay, so we're done with our mapping diagram. Is this relation a function? Remember, what was the statement that we made? What was the function? It's a special relation where each x is matched with one domain. Okay, so each x is matched with one domain, or well, x is your domain with one range, and each one's matched with one, right? So is this a function? Yes, it is a function. Perfect. So yeah, anytime you just get like the straight lines and there's not, you're in good shape. All right, you guys are rocking it. Let's look at example 3 then. Determine whether the following relations are functions. The first one you actually already did, because this was set A from the beginning. This one was not a function, right? Okay. Oh, I like it. Not a function. Okay, and we said because there's 2 2's in the domain. Okay. 2 2's in the domain. Okay. That's one way to think about it. I like it. Range. Uh-huh. So then how about B? Why not? Ooh, but it has 2 4's in the range. It's not the domain, so it doesn't actually matter. It's just the domain. Yeah, so if I made a map, let's make a mapping diagram of this real fast so we can check that out, because that's one that can be really confusing. So we've got 0, -1, 3, -4 for the domain. The range is 4, 2, 4, and -3. So yeah, we got to check this because it's kind of cool. So let's see, 0 goes with 4, -1 goes with 2, 3 goes with 4, and -4 goes with -3. This is totally fine. That's why the mapping diagram can be kind of confusing. But if there's more numbers in the domain and less numbers in the range, you're fine. Because this goes to 4. Each x is matched with only one y. This would give me a graph that we're not going to go there because you wouldn't understand it, so never mind. So this one is a relation, or this one is a function. It's a relation and a function, but okay. It is a function. So that's good that we noticed that and had that conversation. I love it. Okay, so then it says like bonus, find f of 4. This is weird. It's not talked about in your notes, but then it has homework out of it. Like there are several homework questions. I was like, well, that's weird. But it's not hard. Okay, so we're going to come back to this bonus. Well, maybe not. Actually, let's go ahead and look at it. Okay, so it says find the function of 4. So where do you see a 4 up here? There's 2, right? And 2, 4, and 4, -1. Okay, so this is actually saying, what's the function of 4? So if I put 4 in, that's my input. So that's my x value. So what's the number that goes with 4 when 4 is your x value? When 4 is x, what's the number that goes with it? So this is -1. That's the answer. Okay, so if we apply that concept here, we're finding the function of -1. Well, where's -1, my x value? Oh, right here. So it's 2. You got it. If you have it explained to you, it's not hard. It's just like, where is this coming from? Okay, perfect. All right, so then the domain, or your x, is your independent variable because the y depends on it. A lot of times, have any of you ever heard the term input and output table? Okay, it's the same thing. We put the x in the table, and then we get an output. So the x is independent, like how many pairs of shoes we buy at the BOGO sale, right, is independent. It's what we decide we want to do. But the cost depends on how many pairs of shoes we buy. Okay, that's the output. So your x, or your domain, is your independent. Your range, your y value, is your dependent. You probably have talked about that a lot in science even. Maybe. Okay, independent and dependent. Okay, now this is going back to this. It's called, up here where we had this f of 4, is called functional notation. Okay, so it emphasizes the fact that the value of the y coordinate depends on, or is a function of, the x coordinate. So trying to really ingrain in you that like y depends on x. So instead of saying x and y, we're saying x and the function of x, like what we're getting out of that. So we write y as f of x. That's how we read it, is f of x. We just have f parentheses x, but we say f of x, or function of x. So if you look at these, this chart is the exact same. We just changed the label y, to the label f of x. My pen doesn't want to work anymore. Yeah, right. There we go. Okay. Because again, we're trying to get you to see that x is independent, y depends on x. It's hard to see when they're x and y, but here we have x and then the function of x. So what is the y value when I have this x? Okay. So again, like here, so what would f of 6 equal in this one? What's my function of 6? 9. You got it. What's my function of 0? 4. Because I find where my x is 0, and I'm like, oh, okay, well, the function of that is 4. Where my x is 6, the function of that is 9. Perfect. That's super good. Then we have a big giant word problem on the next page. It's actually not a hard word problem. It just takes up a lot of space. So that's always the good news, right? It's not difficult, just spacious. Okay, so the local grocery store is having a sale on potato chips. Who doesn't love potato chips? Right? One bag regularly sells for $2, but if you buy 2, you get a third free. All right, I'd be buying 3 potato chips, that's for sure. Represent the relationship between the number of bags purchased, 0 through 12, and their cost using a table and a graph. All right, so we've got bags, which are x, and the cost in dollars, which is f of x. We're supposed to do this for the bags purchased from 0 to 12. So where do we put that in our table? Do I put it with bags or with the cost? Bags. So we're just going to go 0, 1, 2, 3, 4, 7, 8, 9, 10, 11, 12. Okay. All right, and then we need to figure out our cost. Well, how much is 0 bags? All right, and how much is 1 bag? $2. How much is 2 bags? How much is 3 bags? 4, right? Because if you buy 2, you get a third free. Nice. Okay, so how much is 4 bags? 6, 5, 8, 6 bags. 8 again, because I got the third bag for free. So, right, the 3, the 6, what other bags are going to be free? 9 and 12. That might help you remember even, okay? So how much are 7 bags going to be? 10. 8 bags? 12. 9 bags? Heck yeah. 10 bags? 11 bags? 16. 12 bags? Yes. Perfect. Okay, so I didn't want to give you the chart filled in because I wanted to spend that time like thinking through the word problem part. All right, so then you have a graph. Yeah, we're going to make a scatter plot just like we did yesterday. Okay, so make your scatter plot. Fill that in. So 1 is 2, and 2 is 4, and 3 is 4. What? Okay, I was like, wait. Okay, I was like. Oh, yes, no. I understand what you're saying. I did only make it go to 10. Like, that's the graph size I had, so you're not taking it all the way to 12. But you get a good idea of what's happening. Okay. Lovely. Because we kind of got some stair steps and then it levels off. A platform and some stair steps and then platforms when it's the price is free. So then there are some fun questions there. Question A, are these ordered pairs a relation? You can't see it on my thing because some of you are still checking the graph. So are they a relation? Yes. They're absolutely a relation because one of the things we said earlier was every set of ordered pairs is a relation. Good. Second question, what is the domain? So I'm going to put D equals. Okay, so we've got 0. Okay, so let's see. 0, 1, 2, 3. Okay, we're going to do dot, 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 comma, 12. I like it. We're going to take that little shortcut. C, what's the range? So R equals Bailey DeFries. What's the range? Ooh, 0. Don't forget 0. Okay. Okay, and let's do the same thing. So we're going to do dot, 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 up to 16. Okay, so we've got those even numbers up to 16. I like it. And our last question, are these ordered pairs a function? Why are they a function? Okay, good. So they are a function, okay, because no repeated numbers in domain. That's awesome. The repeats are all in the range, and we can have repeats in the range. I like it. Repeats in the range. Those are okay, right? All right, perfect. Then you all can get started on your homework, and you have 17 minutes. So a good chunk of time again.